This is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 10-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to describe the translations of the cube root function. So before I do that, I want to remind you about this handy dandy table. This is actually a snippet from my last video. I'm just going to pop a 3 right there. And look at that. Now, instead of talking about a square root, we're talking about a cube root. Alright, now while this section is not talking about the a value, I want to remind you, a negative a value is a vertical reflection. If your a value is bigger than 1, you get a vertical stretch. And if a is between 0 and 1, you get a vertical compression. So keep that in the back of your head, because it's a comin', my friends. Now this section is focused on translations. And so translations occur when you add or subtract from a function. So when I look at this function, my h and k values are going to produce the translations that I'm looking for. So h is within the square root house, so the h value translates things left or to the right. Now remember that h feels backwards because of that naughty little minus sign there. So if you get x minus h, it translates to the right. And if you get x plus h, it's going to translate left. The k value is outside of the square root house, and it behaves as you'd imagine. So plus k will translate the graph up, and minus k translates the graph down. Alright, so here we are with the Savis stuff. I'm going to go ahead and zoom in to make it easier for you. Now when I talk about translations or any type of transformation on a function, my cube root function, I actually use these 3 anchor points. I call these the Orion's belt, kind of like the constellation. They occur at -1, -1, 0, 0, and 1, 1. And so those are the 3 anchor points that I always manipulate when I go to draw some kind of transformation. So this function says, how does the graph of g of x equals the cube root of x plus 4 compared to the graph of the parent function? So if I look at that plus 4, it is outside of the house, so that is a k value. So plus k translates the graph up. So if I take my 3 anchor points from my Orion's belt and I scoot them up by 4 units, it should correspond with the anchor points on the red graph. And you can see that right there, it matches perfectly. Notice these points are still equally spaced. It's still up 1 over 1 every single time. If you end up changing that spacing, you'd have some a value right here in front of the square root. That's a stretch or a compression. Let's try it with b. So here on b, it says, how does the graph of h of x equals the cube root of x plus 6 compared to the graph of the parent function? So this plus 6 is inside of the square root house, so it's an h value. And if you see something that says x plus h, that's going to translate left. So if I was drawing this out by hand, I would have my 3 anchor points, my Orion's belt, and I would scoot each of those anchor points left by 6 units. So there's our first one, our second one. Oh, pretend I know how to draw straight lines. And there's our third one. Now, Savis uses the words horizontal and vertical, which is fine. But the thing is there's 2 directions horizontally, and there's 2 directions vertically. So when I describe them, I prefer to describe up and down and left and right as opposed to horizontal and vertical. Alright, so let's get into the try it. So here in the try it, I have a minus 2 that is outside of the house, the square root radical there. Sorry, cube root radical. So that's a k value. And when you get a subtraction of k, your graph translates down. So it's a vertical translation. What direction? Down. Here, this plus 1 is inside of the cube root house. It's underneath the radical. So it's an h value. And so when you get an x plus h, it's going to translate opposite to what you think. So that plus 1 feels like it should go to the right, but it actually translates to the left. And so there we have it, guys. That is the translation of the cube root function. Until next time.